Problem Solving and Prevention Day 2021. System Software Quality and Problem Prevention. Have you thought of the difference between make product right and make right product? Hi, my name is Tamai. Let me introduce myself. I joined Diesel Kiki in 1987. It has been acquired by Bosch. My first career is System Software Engineer Vehicle Navigation System in USA. I enjoyed software development. After that, I moved to Diesel ECU development and I was responsible for process improvement with CMM. I became picky about process. Then I moved to Gasoline ECU Engineering Manager. I loved requirement engineering. I'm also DRBFM expert since 2006. Then last 5 years, I was the Gasoline ECU Development Customer Account Manager. I focused on the customer satisfaction and profit loss. I loved my customer. Since last August, I'm seconded to RBI. I'm responsible for connected and IoT solution pre-selling. Today's my message is, speaking of problem prevention, consider use case as much as possible. Use your imagination to find failure mode on use cases. Let me tell you my summary of the presentation first. Problem prevention in software. Key points are: the problem space is larger. The failure is only the part of it. Make product right can avoid only bugs. Make right product aims to solve customer's problem. Then how? Why don't we join from customer's problem solving phase? Elicit customer's problem. Develop product requirement. Study field environment and use case. Let me move on the first point. The problem space is larger. The failure is only the part of it. We provide product and solution to solve our customer and user's problem. Problem means any issues, new target, innovation, etc. Failure is the only part of it. Why don't we focus on the problem that the customer would like to solve? Let me move on to second point. Make product right versus make right product. This is a well-known pictures in system and software development domain. What are funny pictures in terms of product requirement development? Let me read out one by one. How the customer explained it. How the project leader understood it. How the analyst designed it. How the programmer wrote it. How the consultant described it. How the project was documented. What operations installed. How the customer was billed. How it was supported. What the customer really needed. Funniest pictures are: upper left is different from lower right. Yes. Customer does not know what they really needed to solve their problem. Let me categorize make product right and make right product in this pictures. Make product right can avoid error at design and implementation. Make right product can avoid error at requirement development. Then, how to find out what the customer really needed? To answer it, we should explore what happens at the customer. The customer analyzes their problem and chooses their own solution. The customer explains their solution to the supplier. We must elicit the problem what they really needs to solve. Let me show more insight at the customer on the next page. The problem is, there is no enough play facility at the playground. The customer solved their problem by themselves. They come up to the solution with their own experience. The customer requests supplier to implement the solution A. This is how the customer explained it. Now, what we can do is, the customer solved their problem with the supplier. Identify and share the problem. The definition of problem is the gap between expected state and actual state. In this case, expected state is: the playground has set of facilities such as slope, sandbox, hanging bar and swing. The actual is: the playground has slope, hanging bar only. The gap is the sandbox and swing. Consider the budget and space. The customer decided to add swing only. Now we can define the product requirement to solve the gap. Install the swing at playground. That has at least one sheet. Keep cost low. Utilize available materials. Save space. based on the product requirement and other aspect. The customer and supplier can jointly list up multiple solution options. A. Based on past experience at customer. B. From scratch. C. Supplier proposes its own platform solution. Then, we can create decision matrix to consider decision criteria such as performance, cost, lead time. Key at the system development is consider use case as much as possible to prevent problems in the field. In the best case, the customer explain what the supplier proposed it. Let me summarize it. Involve customer's problem-solving process. Develop product requirement and propose best solution. By the way, what is the example of use case on the swing example? For example, what if thunder falls onto the tree? Kids falls on the ground. Ground under the swing is muddy under the blue sky after the rain. Remember, elicit customer's problem first. Consider various environment to derive use cases. Use your imagination. Now, let me show the real example in PSEC gasoline ECU software on the next page. Example, air-by-fuel control. The customer has the problem. The engine often does not start promptly at the cold start. The reason is the wrong air-by-fuel ratio. Actual ratio is more fuel-rich. But, ECU thinks it is balanced. How the customer explained is, to give more air, as their request. Key point is, we must start from the point which is, make air-by-fuel ratio balanced. Increase air, or reduce fuel. Supplier can propose to reduce fuel as the platform solution. The customer and supplier jointly make a decision by using decision matrix with criteria such as response time, accuracy, development cost. More according to the use cases. Let me recap. Problem prevention in software. Key points are: the problem space is larger. The failure is only the part of it. Make product right can avoid only bugs. Make right product aims to solve customer's problem. Then how? Why don't we join from customer's problem solving phase? Elicit customer's problem. Develop product requirement. Study field environment and use case. Use your imagination to find failure mode on use cases. Today's my message is, speaking of problem prevention, consider use case as much as possible. Use your imagination to find failure mode on use cases. Thank you.